Hey there, everybody. We're back for daily space weather video number 3 of 3 on the day, starting out with the total electron content forecast. We are seeing some chaos in the electron bands here, some GPS errors over Canada and other parts of North America, also nighttime GPS errors over Antarctica. We'll let it play through a second time here. The total electron content forecast will show you the free electrons in Earth's plasmaspheres and inner Van Allen belt. Your GPS could be off by thousands of miles if you have one of those red blobs overhead. People living around the equator are aware of this. So here's a diagram of what we're looking at basically. This is your GPS satellite located about 12,500 miles of altitude. And the total electron content forecast includes that area. Charging hazards have subsided since yesterday, so we saw some significant charging hazards yesterday. We even showed some examples of what that can cause to happen in yesterday's meteorology segment. Here's the one-year chart of the relativistic electrons. And we're seeing quite high levels here again. They finally subsided. They were at over 10 times warning levels here yesterday. And now we've seen them dip a bit. Little lower levels, little more nominal levels of electron flux there. Forecast model is for a big dip, and this will be associated with a coronal hole high-speed stream. A large reduction expected in the electron flux. Next, looking at the ionosphere layer, the F layer is located at about 300 kilometers of altitude. If you need to pause that frame, feel free. It's showing thermospheric temperatures and electromagnetic radiation penetration and molecular species. Here's the F ionogram, the ionogram in megahertz of the F layer. We'll also show you the anomalygram for those of you who are not familiar with looking at the ionogram. It'll help to show you anomalies from the 30-day median. Here's the anomalygram. So high-frequency anomalies around the equator, quite a bit of those. Some wild shifts over South America, we see that regularly. And we'll let this play through. We'll show the latest image on both the ionogram and anomalygram. There is the ionogram at 11:30 Universal Time, and there is the anomalygram at that same time. Let's continue through, blasting through additional bonus features. Welcome to the Neo Renaissance. Please visit our links. You can find them below the video. You can find them at smashomash.com. You can find us all over social media. Welcome to the Neo Renaissance. Did you know we're writing a paper explaining plausibly the mechanism underlying the solar sunspot and solar polar field reversal cycles? Help us out. Become a member of the Smash team. Maybe pick up some merch. Here's our merch. We've opened it all up for sale throughout the month of February. Come March, we're going to have a limited selection. So if you've got any selections there that you'd like, pick them up now in February. They may be gone next month. If you enjoy the content and prefer it to remain publicly visible, please consider becoming a member of the Smash team. We've put up some recent posts here, which we can't even show. They're only available to Gold and Silver Smash team members. We replaced Patreon with a superior subscription service as our own website. Did you know we're also on Facebook? Facebook.com/Smashomash. You can find all of our posts there. Shout out to Smash staff. Thanks for every day posting all of our content all over social media. Let's continue on with bonus features. Starting out with very current data here from Cerro Tololo, Chile. It's only less than 2 minutes old from the time we recorded the video, and we've got massive filaments on the Earth-facing side of the sun. So we've got filaments, 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 and more filaments. Likelihood of coronal mass ejections, very high. And remember, folks, we don't need to see a solar flare to see a coronal mass ejection. Never confuse causation with correlation, folks. Next, the latest intensitygram and colorized magnetogram. Sunspot 2948 is the most interesting sunspot. It's still beta gamma class. The rest are kind of fizzling a little bit. That's still beta class, but looking weaker than yesterday. So there's possibly a new sunspot forming there. That looks like it's going to be a sunspot. We also saw another sunspot rise down here. Here's the colorized magnetogram. There are the fields of sunspot 2948. If we are going to see a large flare, that would be the most likely place for it. It's not that large of a sunspot, but let's take a look at the GOES 16 SUVI next. It's great wide field of view, fantastic at showing solar prominences, and we see some filament dancing up here in the northeast. Again, tons of filaments on the Earth-facing side of the solar disk. Don't be surprised to see coronal mass ejections. We got a small crown prominence also up here right at the end of the video, right there. Little crown prominence. By the way, crown prominences are associated with solar maximum. Let's close things out with some additional SDO imagery here. This is 1700 angstroms plus 335. And you can see all those bright spots there. Those are higher concentrations of the specific species of iron, which vibrates at a frequency of 335 angstroms. At a wavelength of 335 angstroms, rather. It's all part of the ultraviolet light spectrum. And we'll close out here with 304 angstroms. See all those filaments, all those dark areas there. You can see filaments down here, filaments up here, and so on. So anyway, thanks for tuning in to the Daily Space Weather video. Congratulations on realizing the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least posted name in news.